rotates to spread the scrap over the furnace bottom, then tilts again to receive its charge of molten iron. It will turn these ingredients into 255 tons of steel in just 33 minutes. A pipe, called an oxygen lance, is lowered into the furnace. It will blow oxygen into the furnace at high speed, creating intense heat, often 3,000 degrees Fahrenheit. The oxygen combines with carbon and other unwanted elements, eliminating them from the molten charge. With those removed, the iron becomes steel. Other metals or alloys are added to make the type of steel desired. During the process, samples are taken of the molten steel for immediate testing. If the tests are satisfactory, the furnace is tapped. The end result is a ladle of steel of one specific type. Nobody can use 200 tons of molten steel, so next it must be cast or solidified into a form convenient for shaping. A modern energy-saving method of shaping steel is called the continuous casting process. It changes steel from a molten to a solid state in one continuous action. Here's how it works. From the ladle, the molten steel pours directly into a copper mold, which is water-cooled. The cool mold causes a skin to form on the surface of the steel. The skin becomes thicker as the steel cools from the outside toward the center, gradually becoming solid throughout. From one type of caster, the steel emerges in the long, narrow shapes called billets, from which bars are made. From another caster, the hot steel comes out in a wide, thick slab, which is cut into desired lengths. Our sheet steel will be made from this slab. First, it is reheated. Then begins its journey through the hot strip mill. We're about to see our thick slab rolled into a thin sheet nearly 3,000 feet long. Operators, with the help of computers, control the speed of the slab and the pressure of the rollers. Each set of rollers compresses it a little more. And in a half-mile run, the slab goes from thick to thin. Rolled into a coil, it is now suitable for many uses. But it is not yet our final coil of steel. As we've just seen, while steel is hot, rollers can compress it into another shape. In other parts of the plant, rollers are squeezing steel into structural shapes. Into bars, long and thin. Meanwhile, our coil of steel is cooled. After being cleaned, it's fed into another mill for cold rolling. The operator sets the pressure to bring the steel to the exact final thickness desired. Cold rolling has hardened the steel. To make it suitable for forming into many shapes, a cover called an annealing chamber is lowered over the coil to reheat it evenly. After annealing, the steel will be lightly rolled again. Finally, this steel order goes through the galvanizing process, receiving a zinc coating to protect it from rust and corrosion. Now the millwork is done. The rocks have become sheet metal. And who knows, steel from this very coil may have been shaped, painted, and made into the body of the next automobile you see.